Hello and good afternoon. Thank you again very much for this kind introduction, and of course, thank you very much for having me here today. My name is Isabel Eiser, as you already told the audience. I am a research assistant and late-stage PhD student at the University of Hamburg, and I'm here on behalf of the whole team of the DEWISE project at the University of Hamburg, where I'm working as a research assistant. The DEWISE project is led by Professor Dr. Gertrud Koch, and Professor Dr. Chris Biemann is head of the informatics team. You can see the names of the rest of the team here on this slide. In this paper today, I will present you an overview of this research project. First, I will introduce you to the project's infrastructure and research goals and talk a bit about why such research matters in sense of digital approaches to discourse analysis. After that, I want to talk about the three areas of focus in our project: the hermeneutic approach in the DEWISE project, the co-creation concept, and of course, the prototypical working environment we are developing. The DEWISE tool suite. I will give some details on technical features we already implemented and plan to implement in the future. Currently, the tool suite is in an early prototypical stage with the basic functions. Due to this early stage and my affiliation with the humanities, I will talk more about our research bridging social science and informatics, our methodological approaches and project goals. And only in the end, I will give a short technical overview of the software and its features. The DEWISE project is a BMBF-funded joint project between the informatics and humanities at the University of Hamburg. The interdisciplinary collaboration includes a team of researchers with the humanities represented by the Institute of Anthropological Studies in Culture and History on the one hand, and the Language Technology Group at the Department of Informatics on the other hand. Starting in May 2021, in this project, as I said, currently in a very early stage, we aim to research and develop central innovations for digital discourse analysis. We especially want to address challenges researchers are facing regarding the reflection of their work and the increasing dealing with open corpora, consisting of large quantities of heterogeneous materials. To address these goals under the umbrella of the DEWISE project, manual and digital approaches to discourse analysis are combined and reflected to develop this prototypical working environment for digital qualitative discourse or data analysis. This new qualitative data analysis tool, we call it at this stage DEWISE tool suite, is built up in a process of close exchange by the two teams from the humanities and informatics. The collaborative approach focuses therefore mainly on two parts. First, and obviously, the development of the tool suite itself and a useful expansion of digital features, especially regarding the handling of multimodal data, big data, as well as reflection and documentation processes of the researchers, analyses, and interpretations. Under the premise of human in the loop, it innovates both informatics technology of context-oriented embedding representations and hermeneutic methodologies for discourse analytical approaches that are sociologically and ethnographically oriented. Secondly, the worth of the project is can be found on the conceptualization itself. Central part is therefore the hermeneutic approach, the epistemological reflection and further development of hermeneutic methodology and the use of semi-automated processes. The project wants to bridge the gap between the manual and the digital. This includes not only bridging the professional gap, so to say, and questions of technical feasibility on a meta level, regarding the collaborative co-creation between the research of humanities and informatics. This especially means bridging the gap on a technical and discourse analytical level between structural patterns detected through digital methods and hermeneutic and interpretative processes of human meaning making. If you want between qualitative and quantitative approaches too, or structural and close readings. For developing central innovations for qualitative data analysis and in what we call manual approaches, already available features and tools and their technical and methodological usability are tested, reflected, and evaluated by internal and external researchers from different fields of the humanities together with the informatics team. In this co-creating approach, in this cooperative project between the informatics and human sciences, we aim at finding solutions and reflecting on questions like the following. How can digital humanities methods and tools be adapted and new methods be developed for this purpose? Semi-automatic processes be meaningfully integrated into qualitative discourse analysis knowledge production? How can existing methods be adapted and new methods be developed for this purpose? What needs are communicated by researchers and what hurdles do they experience when it comes to digital analysis and quantifications or datafications of discourses? Producing countable data from social phenomena to create visualizations or make sense of discursive trends. And more specifically, in our case, which of these needs and how can these be integrated into the device tool suite in questions of technical feasibility, but also time expenditure. Before diving deeper into the project's technical and methodological research, let me shortly introduce the basic concept of discourse analysis and how digital solutions matter for this methodological approach. Discourse analysis wants to study the discursive construction of reality, of knowledge or of power-knowledge relations, following the assumption that language use in discursive practices constitutes the objects it deals with as knowledge. The statements and the corresponding statement practices from discourse, if they are formed according to one, and form a discourse if they are formed according to one and the same formation principle, as Rainer Keller calls it. The basis of digital approaches to discourse analysis are coding processes following grounded theory, annotating and extracting quotes from transcripts, creating codes, subcodes, and parent codes in the sense of code families or concepts or topics. The analysis of discourses works in circular processes or hermeneutic circles of search, selection, analysis, and interpretation of research data, supported by literature work and performed iteratively until the research question is answered. These basic operations of discourse analysis prepare the grounds for the intertwining of hermeneutic epistemic processes of discourse analytical approaches with the structural methods, like we call it, provided by digital tools assembled in the tool suite. Users performing qualitative analysis, like in discourse research, can be powerfully supported with digital solutions, algorithms, and AI-guided filter mechanisms to address research processes of tagging, of coding, annotation, analysis, and interpretation. Automated or semi-automated functions support such analysis processes and the filtering of relevant materials, like Gerhard Koch calls it. For example, a theoretical sampling or the development of categories or simultaneous data expansion. The use of tools from the digital humanities for discourse analytical approaches is by now state-of-the-art, and there are already several different open source or licensable digital solutions for qualitative analysis available. Some of you might know it, for example, MaxQDR or Atlas TI. These are the two big fee-based computer-assisted qualitative data analysis softwares. These tools are trying to offer like all-in-one solutions. Other relevant non-profit open access tools include CAPMA, Voyant, Label Sleuth, Syntax, or InsightsNet, or even Zotero is offering as a reference manager the feature of annotation. Many digital methods and features in such tools are already successfully enriching literature studies or discourse analysis. Semi-automated coding processes following grounded theory, digital annotation, topic modeling, word counting, co-occurrence analysis, sentiment analysis, or visualizations of quantified discourses offer insights into discursive patterns, trends, and conjunctures. They support the methodological guided reduction of bigger data and serve the identification of potentially relevant data for manual processing, analysis, and interpretations. But existing tools lack digital and semi-automated solutions in certain areas. For example, regarding the handling of multimodal data and the phenomenon of materials, including plurality and ambiguity of meanings. The challenge of multimodal data, meaning in this case, the work with texts and images, or even a combination of both, is not an easy task for digital analysis processes. But for many researchers, there is a communicated need for combined approaches to texts and visuals, and to extend the limited scope from textual discourses to visual discourses, which are increasingly shaping everyday communication, as we know. Researchers are also increasingly confronted with masses of material and the challenge of organizing, handling, and filtering of this big data, not only in crawling processes, but also in data management, as well as in the process of analysis. Big data might be one of the main challenges researchers working with extensive approaches are struggling with. How to condense or filter the masses of available material to a relevant data set and support the user in creating a core dossier that can be analyzed in close reading. It can also be observed that there is by researchers communicated need and potential for, let's say, development when it comes to critical reflection and documentation processes of the own digitally supported analysis. Documentation processes are understood as a key element in qualitative or discourse analytical research. In a framework of digital research, we want to enhance the possibilities of documentation processes in digital tools to make the user engage more actively in reflections on the role of AI in the own research project, and the difference between structural and interpretative approaches. Working with digital tools is challenging its users as it presupposes an extensive technical understanding of all-in-one solutions that are overpacked with features. While the access to digital tools, which are not open source, is a hurdle, it is also digital functionalities and its processing, which are often not transparent in their implementation. This is a problem for researchers working with a black box, not knowing how to describe the processes of digital research, its outcomes, and to assure scientific standards. So with DWISE, we aim to address these lacks or this lack of digital solutions for research reflections and documentation in multimodal discourse analysis, consisting of big data, which provide multiple challenges and complexities for manual, but especially digital solutions. So the question is, of course, how can digital methods and features be adapted, improved, or newly developed and meaningfully integrated into qualitative discourse analysis production? using and analyzing existing tools and related work, like I introduced, in this close exchange between humanities and informatics, help us to understand the needs and gaps in digital solutions for qualitative research and more specific, the analyzed processes. Such co-creation concepts are increasingly implemented, especially in the digital humanities research projects. The intertwining of social sciences and informatics is widely agreed upon as crucial for evaluating and developing methodologies and technologies and digital approaches for researching social phenomena and discursive processes. These co-creation concepts between humans on the one hand, but also between humans and non-humans like digital infrastructures on the other hand, offer challenges and potentials for both hermeneutic research as well as software development. It makes possible the epistemological reflection and further development of hermeneutic methodology in the use of semi-automated procedures regarding technical questions on how automation can be usefully integrated in these approaches. So together with researchers from the informatics, these hermeneutic reflections are translated into innovating technology of context-oriented embedding representations. While in traditional software development, the customer defines a specification sheet and the developer implements the communicated requirements, in usual co-creation approaches, the software development becomes agile by including users, leading to rapid prototypes based on already established methods and technologies. In the device project, on the other hand, the approach methods and technologies are in parts research prototypes in a still highly experimental stage, which are not yet established. While this working mode differs from classical co-creation concepts, it requires in-depth cooperation, going through several phases of collaborative creational processes. Before stepping into the traditional mode of co-creation and prototypical integration, in a pre-phase, the methodological usefulness and technical capability of functionalities and their utility understood and reflected via, we call it hands-on testing in close collaboration. Methods and research approaches like hermeneutic analysis and co-creative research designs, as well as technologies, the tools itself and the digital applications are tested together hands-on to reflect and make sense of their use and determine their suitability before integrating them prototypically following the more classical co-creation. And in an additional step, the prototypical experimental technologies are operationally understood to determine if they are useful enough to be prototypically integrated. This is particularly important in the case of AI technologies and data-driven methods, since one cannot deduce their usefulness for the subject-specific scientific question from their definition. To conclude this small part, co-creating multimodal analytics for hermeneutic discourse analysis in the device project leads to first identifying common principles and negotiating priorities for software development, and the following mutual reflection and innovation of methods through co-creation with internal and external researchers shall foster multivocal forms of research to make the system more stable for users and approaches from different disciplines. A major interest of the project is to contribute to a human-centered approach, which is a sign in AI development becoming stronger. In the center of this development, key questions are how humans and AI interact and in which way this interaction can aid human needs. One of the crucial places where this issue resides and the question determines if AI approaches are human-centered is the loop, a most important component of learning systems. loops are implemented for providing feedback. Hence, they are essential for learning by giving an opportunity to correct, to improve, and evaluate results in AI, as well as for human learning, for developing further information technologies that can allow us to benefit and learn from each other. So bringing not only the human, but also AI alternately in processes of data acquisition, analysis, and interpretation can be enhanced by AI, as well as AI processes can be enhanced by human interaction in combination with machine learning processes. In a constant combination of manual analysis by human agents and its provided feedback loops, digital automated functions are simultaneously developed to the needs of the human scientists and the detected shortcomings in critical analysis of existing tools or manual analysis. In the following last part now, I will present how these ideas of processes of implementation are happening, what the current status of the core functionalities of the tool are, and of a perspective of what the tool will offer in the future. Maybe my colleagues can help with later upcoming technical questions on this. The tool suite is a web-based open source tool for digitally supporting, like I said, sociologically and ethnographically oriented discourse analysis, where these hermeneutic circular methods, filtering, scalable reading, and coding are predominant principles. Furthermore, collaboration, the complementary combination of human in the loop and AI in the loop, multimodality, and as I said, big data are the core themes and were consequently considered from the beginning of the tool's development. For improved modeling of the plurality of meaning and the integrated processing of multimodal data, contextualized embeddings are developed to expand the existing range of methods and support and enhance reflective research via AI supported functionalities and semi-automated processes. So as the tool suite is in a current state of a prototype offering basic functions like annotation, search, and logbook, also first structural analysis are possible. I would like to introduce three main features for now, starting with AI-supported data pre-processing. One of the main areas of application in which artificial intelligence-based algorithms are used is data pre-processing. This process is triggered when text and image documents are added to a project in the tool suite. The goal of data pre-processing is to automatically extract metadata, entities, and statistics from the documents using AI. Moreover, each document is analyzed and added to a specific cluster, enabling features and such as semantic multimodal similarity search or lexical search. The following is like a superficial description of the steps that make up the pre-processing process. After a user uploads one or more documents, the steps are applied consecutively to each document. In the first, a distinction is made between image and text documents as different steps are applied depending on the modality. For text documents, the automatic recognition of entities such as people, organizations, or places follows. The recognized entities are stored as annotations in the document and made available to users, for example, via search or other analysis functions. In the current version, texts in English or German are supported, and depending on the language, different AI models are used. Documents with mixed or other languages are processed with the English transformer models from the Spacey library are used for this purpose. And in the next step, word frequencies are computed. In the subsequent step, semantic representations of the document are computed using contextualized word embeddings and AI models developed for semantic similarity search. In addition, the multimodal clip model is used to compute another representation of the document, so that it is also available for multimodal search for searching visual and textual data and analysis functions. All representations are then stored in special clusters optimized for efficient search. And in addition, the documents are added to an Elasticsearch index to enable efficient lexical search. In the first step of the automatic pre-processing process for image documents, the current object recognition and object classification is brought into use. DETR is brought into use. Recognized objects are stored in the image in the form of annotations similar to text documents. Image annotations are, like you can see here, such rectangles that highlight regions in the image and describe then with a texture code what you can see or what it identified. And the next step, a public pre-trained multimodal AI model, which consists of a combination of vision transformer and GPT-2, sorry for the technical features, maybe someone is interested in it, is used to generate an automatic textual description of the image. This image description can be viewed by the users and is also used internally for other features. And the final step, similar to text documents, the multimodal clip model is used. I introduced it already to compute a semantic representation of the image. Since the same model is used to compute representations for both text documents and images, they can be compared with each other, which is the core of the multimodal similarity search. Another feature is, of course, one of the basic features like the searching and filtering, which is, of course, an important method, an important basic method of discourse analysis to find relevant documents that increase the diversity of arguments in the social discourse under investigation. The device tools it offers typical search methods such as full text and keyword search, and in addition, documents, of course, can be filtered based on manually and automatically created annotations or codes. Thus, automatically generated annotations can support not only the analysis itself, but also the basic search process. Furthermore, the device toolsuite offers AI-supported multimodal search methods. Here, as described previously, special AI models are used to represent documents from different modalities in the same search space. This enables multimodal queries. Thus, query can be either an image or a text, or in the future, hopefully a short video or audio clip, and documents of all mentioned modalities can be found. In the search interface of the device toolsuite, as you can see here, users can create filters that represent the various search methods described above. By adding new filters to a search query, large corpora can be further reduced until a collection of documents is found that is manageable for human processing. The documents found can be worked with directly, or the search results found can be saved as a collection for later analysis. Of course, we have to talk about the feature of coding as one of the most important features, maybe. An essential component of this tool suite is, of course, the annotation or coding of multimodal documents. This method can be used to effectively find and analyze patterns and concepts in data in order to discover and elaborate on existing phenomena. In doing so, the device toolsuit supports the three typical coding phases of ground theory. Open coding by simply creating new codes during the coding process, and also the actual and selective coding by providing functions to update codes, build code hierarchies, and subsequently merge codes together. So you can see that here in the annotation view with the code hierarchy on the left and the annotator during code creation on the right. In addition to the annotation of passages in textual data, the device toolsuite also supports the annotation of regions in images as well as encodings on the document level with code spanning levels and modalities. This allows relationships to be detected in the analysis independent of annotation level or modality. In the future, sequences in audio streams and passages in videos will also be annotatable. To improve the traceability of decisions and enable collaborative discussion, all elements involved in the coding process can be annotated with memos, documents, codes, and annotations. This is an important feature also for the process of reflection and documentation, of course. And important collaborative functionality is displaying annotations and memos from other users editing the same document to find and discuss potential inconsistencies. And it also provides AI-assisted automatic annotation so that manual annotations can be scaled to large corpus to extract insights from all documents at hand. Taking notes of newly gained knowledge during research, like with memos or in a logbook, is essential to effectively tease out patterns and phenomena. Therefore, we want to offer the possibility to create memos to record thought processes and attach them also to various visual objects such as codes, documents, or annotations. To keep track of such memos, the toolsuite provides an interface for browsing and sorting these memos and notes and ideas. And it also provides an overview of all actions, such as assigning code to a document, creating a visualization, or creating document collections, so that it is possible to track what has been done in recent sessions and what has changed and which decisions were made and why. Also integrated into the toolsuite is, for this purpose, also the logbook to detail summaries of a session or phenomena discovered. We think that researchers can work more effectively with these functionalities as there is less need to switch between different applications to write a comprehensive documentation of the research process. And these comprehensive documentations can become very extensive and hard to handle. In the upcoming and following toolsuite versions, the focus lies on extensibility, probably. In particular, the integration of AI-supported speech and video processing technology and application-specific AI models, such as for entity linking, will be further advanced. Generally, more tools and features will be integrated, of course, to support hermeneutic research processes, combining manual and automatic methods. The semantic crawling of numerous multimodal big data sources shall be enabled, and also the automatic scaling of annotations across large multimodal corpora will be possible. At the same time, the aim is to enable configurability of the application without programming in order to adapt the toolsuite to specific projects. By adding import and export functionalities in common formats, the collaboration with existing software and the use of existing datasets shall be enabled. In sum, this should support additional use cases in the digital humanities outside of different discourse analytical approaches.